Okay, so at the end of last video, yesterday, I guess it was yesterday, or the previous video, whenever it was, I was talking about PID tuning, but there was no sound. So hopefully we have sound today. It looks like we have sound at the end. The rest of the video was fine, but that scene didn't have sound assigned to it. So we're going to do PID tuning again. This will be a shorter video just talking about PID tuning and why you might want to consider that and what it does. I'll turn the light back on. It went off there. There we go. And we're talking about calibrating, setting up your printer for the first time, and we'd walk through kind of how you can look at some of the mechanics of it, you know, the physical arrangement of parts, the belt tension, are things square. We had talked about E-steps, and then we had gotten to PID tuning, and that's when our sound dropped out. So what PID tuning is it's an acronym. PID is proportional integral derivative. And the goal of PID tuning is not specific to 3D printing. It is a control system method that helps you reach and maintain some set point. So in our case, the set point that we're interested in is the hot end temperature and the bed temperature. So they're both interesting to us. Normally it's more the hot end temperature, but also the bed temperature. So one way you might think about a control system that's going to control temperature would be that I create a set point. So I want the nozzle to get up to 200 degrees Celsius. That's my normal, or 205, you know, whatever my normal printing temperature is. I want it to get up to there. And so I would obviously have to turn the heater on. And then I give it some amount of gain. So how much energy do I want to put into that heating element to get the nozzle up to 200 degrees? And so however far away I am from 200, maybe I'm at room temperatures or like 20 something degrees, and I want to get to 300. There's a big delta, a big gap between the 200 and where I currently am, so I give it a lot of gain. So that's proportional to that gap is how much gain I want to do. So that's the proportional part of PID. And if you only had that, so that would work, right? You would turn the heater on, crank it all the way up, and your temperature would start rising towards 200. And then when it got to 200, it would turn off. The problem would be that gain that I assigned was so much that I'd probably overshoot 200 and go to like 210 maybe. And then the heater's off and it comes back down and it starts dropping, and now it's going to drop below 200, and then the heater will kick back on and it'll go back and it'll probably shoot over 200 again, and so it'll bounce or oscillate around 200 quite a bit. And that's not great for if you're trying to maintain some particular set point. And but there are control systems like that. So if you just have the proportional part, then those control systems are called bang bang. So right, you turn the temperature off, and then it gets above some threshold, and bang, you turn it back off. Turn it back on when it drops. Turn it back off when it gets too high, and so that's bang bang. A lot of printer beds are set up that way. Not everyone, but a lot of them are set up that way. Speaking of that, so this is a little bit of a side note. If you ever have a print, so you've got a print, and you see along the side of it, you know, maybe it was printed this orientation, there are these little bands. They don't really look like over extrusion or under extrusion. Maybe they don't look like discoloration or anything. They just are periodic bands in the printer. Some people might attribute that to Z wobble. So the lead screw for the Z axis is wobbling back and forth and creating those bands, which can happen. But if you've sorted that out and it's straight and nothing seems to be wobbling, then it could be that the printer bed itself is set up for the bang bang tuning, where if the printer bed is just a flat surface, and then you heat it up and it deforms. Maybe it deforms upwards, so it kind of bends upward. And we're talking sub-millimeter level of deformation here, but it deforms upward, and then it gets to its set point and goes above it, and then the heater turns off and it deforms flat again, and back and forth and back and forth. And that little part you're printing is sitting on the bed, moving up and down, sub-millimeter, but still, it moves up and then down, up, down, and it creates those bands in the print itself. I don't know if there are too many printers that still have bang bang tuning on the bed. You usually have enough firmware room. You know, it used to be where the limit on the firmware was how much memory there was on the board, and you were scrambling to, all right, I really want that feature, so I'm gonna have to leave out these features. Now the modern boards have enough memory built into them that you can pretty much have all the features you want. But you might have a printer that doesn't have PID tuning enabled on the bed, and it could have that kind of situation. So that's just an aside. You probably can enable PID tuning on the bed. If it's not, we'll actually look and see, does our printer have PID tuning on the bed or not. So some printers, not this one that I have over here, but some will let you go to the control panel. So go over here to the control panel, and they will let you do PID tuning right there in the control panel. You know, it's just in the, I don't remember if it's in the control menu or what menu it's in, but it's just right there. This one does not have that, so we're going to have to do it another way. The way that I'm going to show you is more universal. It will work with, should work with any printer, any of these style printers anyway, unless your firmware is just locked down and you can't access it. But this one, sometimes you can do this right on the menu screen. It's really easy, and it kind of is all automated. We're going to have to do a little bit more manual. So what we're going to need to do, let me get that, because we need to see, oh, it's off the table. There we go. We need a USB cable, and we are going to plug it into our printer. The other end of this USB cable is plugged into my computer. So you'll actually see, maybe, it's kind of covered up, but you actually see the screen come on. Like the printer is getting some amount of power. The printer board is getting power over here through this USB, and it's turned on the printer screen. You can't really do much, but you can interact with the screen. That will happen pretty much no matter what USB cable you plug in. The problem is that not all USB cables will actually work for what we want to do next. You need a data cable. So you can check, you know, plug your phone in with this same USB cable, and if you can access your phone from your computer, then that's a data cable. If it just goes to charging but no connection, then it's just a power cable. So that can create a problem. You grab some random USB cable, you plug it in, it looks like, you know, this comes on, the screen comes on, it looks like everything's fine, and you never can connect to your printer. That could be the problem. Could just be you have a power USB cable, not a data USB cable. They look pretty much the same. Well, they look the same. Another problem that you could run into is maybe you've been using a slicer like Cura, and you need to completely shut down Cura, because Cura and other slicers will take control of the printer. Hold on a second, we'll be right back. Okay, we're back. That could be a problem. Cura will take over the USB cable, and the software that we need to actually talk with our printer won't be able to access it. So that's a problem. And another problem that could happen, now you'll notice that, well, let's go back to the printer. I don't have the printer powered on. So I've actually got the USB, it came on, the printer screen came on because USB is powering it, but it isn't actually powered on. Sometimes if you already have your printer powered on, you also won't be able to connect to it. So I've got the printer's main power off, data USB cable plugged in, Cura is not running, slicer, none of those are running that might also want to talk to the printer. None of those are running. Now I'm going to open a piece of software called, it's a weird name, but it's called Pronterface. So here it is. And it's an old piece of software. It's open source, freeware type of software. You can download it. You actually look for print run Pronterface, and you should be able to find it to download. There are others. This is just the one that I've always used, and it works pretty well. It's not very complicated, I guess, so I'll use it. Over here in the top left, you're going to need to find your COM port. Mine should be COM 5. COM 1 is probably the mouse or something, so COM 5. Usually this baud rate is the 1000 or 115,200. That's usually the right one for your printer. And you hit connect. All right, printer is now online. I got that message over here. Now I'm going to turn on the printer power. I know that with this particular printer, I have to do it in that order. Other printers, the printer can already be on and I can talk to it, but this particular one, printer main power off, USB data cable plugged in, Cura off, Pronterface connect, then turn on the printer power. So now our printer can talk to our computer through Pronterface, and our computer through Pronterface can talk to our printer. So first thing we're going to do, this little box down at the bottom of the screen, I don't know if you can see the box. I don't know if you can track where I'm down at the bottom over here. Do I have a mouse? No. All right. I can type G-code commands into here. So I'm going to type M503. This will send the code M503 to the printer. The printer will respond with all of its firmware settings. So there they are. So the echoes into this window here, terminal, are the printer sending all of its settings to my computer. And right here, you can see two sets that have P and some number, I and some number, and D and some number. Those are PID tunings. You could have more, and you could have just one. If you have just one, it's the extruder. If you have two, you have to start figuring out what they are. Because you might have multiple extruders. This printer only has one, so I know there's only one. This printer does have a heated bed. The 301 number here is your extruder. If you have multiple extruders, you'll have 301, and then there'll be a E0 for extruder 0, or E1 for extruder 1, which is the second extruder, and so forth. 304 is the heated bed. If somehow you have a heated chamber, I don't know what that number would, that may not even be a PID tune, that might just be a bang bang tune on that, and it may not even be in the printer firmware. That would be a very different printer than what we have here. All right, so I do have PID tuning on the bed and PID tuning on the hot end. So these numbers with P, I, and D, those are the coefficients that go with the algorithm to create the tune to begin with. Those are the numbers that I want to see if they're correct for my printer, where it's at, because the ambient temperature is going to affect it. What temperature I want to print at will affect it. So what I want to do is I want to get up my printer set up in a way that is the typical way I'm going to print. So for this printer, it's going to sit on this desk. It's going to print right here. If I ever move it, I might want to do a new tune on it because it'll be in a new location, and maybe there's an air vent that's near it, or maybe it's a hotter room or a colder room or a window or something. So I might want to retune it if I change something. I might want to have different tunings for different filaments. You know, that's possible. I'm going to mostly print PLA and PLA-ish materials on this printer. So I'm going to load it. I've got the printer loaded with my PLA. Well, it's off the screen, but I've got it loaded with my PLA filament all the way down to the nozzle where it normally would be. PLA normally has this fan turned on, so I want to turn that fan on. I'm actually going to do that in the Pronterface. To turn on a layer cooling fan, I need another M command. M106 is the layer cooling fan. And I need to tell it all how much do I want it to turn on. So I have values between 0 and 255. So that range is based on the number of bits that are associated with turning the fan on. And so 0 would be off, 255 would be 100% power, 125 would be 50% power, and so forth. I'm on it full blast, so 255. And I heard the little fan come on the side. So now it's got the layer cooling fan on. It's loaded with filament. Now it's in its state that it would normally print in. You may even want to like lower the nozzle to turn the bed on, all those kind of things. I think those are not as necessary because as the print moves higher, then it's going to get away from the bed anyway. So I don't think the bed's worth turning on for this purpose. So to do the actual PID tune, we have another command, M303, for the hot end tuning. And we need a set point. I'm going to normally print PLA at 205, so S is for set point 205. And then I can add a C for how many cycles am I going to attempt for it to gather data from. Now, if I were doing this for actual calculations, I'd probably do like 8 cycles, at least 5. For demo purposes, I'm going to do 3 so it doesn't take as long. So that command, now if I can, there are other triggers that are parameters that I can put on this, like if I have a different heater, like 2 extruders, I can tell it I want to do E0 or I want to do E1, and so there's other parameters. This is all I need to get the one hot end that I have to cycle 3 times around 205, and the data will be collected and processed to calculate new values for P, I, and D. So PID autos tune start, that's a good sign. You'll notice over here in our little window, you can click on this if you have Pronterface actually open. You can click on this and the window will get bigger. It just won't show up on your screen since it's a new window. But you can kind of see the E0 or EX0 line is starting to creep up, and it's going to do that. Go to 200, probably go a little above 200, turn off, on, off 3 times. And then we'll get some new values for P, I, and D in our printer, and we can assign those. That won't actually put the values in the printer. It will just tell you what they could be based on the algorithm and your current setup. So now all of these steps are written out in the description for the video, so you can open up the description and see all the steps written out there in case you forget any of them. Let's see. So it looks like we're around 150 or so right now. Let's see. Let's talk about the other. We talked about proportional, what P meant for proportional. The I is integral. So that's the calculus version of integral, like I integrated an equation. So calculated the area under the curve. So what it does, if I just have proportional, then I get all this overshoot and undershoot, and I'm constantly cycling around the set point. And I'd rather like go up to the set point and meet it, not cycle above and below it. So the integral thing kind of helps with that. If I integrated the existing, like you can kind of look at our little graph here, and I've got a curve, and I could calculate the area under that curve, and that's integrating it. And so now I'm kind of looking at the past, looking at what it's been doing, and by integrating the area under the curve that of the heater as it heats up in the past, I have kind of got a snapshot of, okay, this is the things it's been doing over time, and I can use that past data to kind of adjust for what I want to do next. And the D, if you're thinking, well, integral I is calculus integrate, D is calculus derivative. And that's right, it's a derivative of that same graph, the same little temperature graph. Now you can kind of see, small, but you can kind of see our cycles happening in our temperature graph. The derivative is the slope of the line, so the rate that it's doing stuff. So if I know the slope and where I'm at and where I've been, then I can kind of predict the future. Because I know the rate I'm moving at right now, I kind of have some history information. I've got this, how much gain have I applied to it through the proportional constant, and I've got the derivative now, and I can predict the future. So if I have past data, current data, and a future prediction, then I can have much more control over what I need to actually do. Do I turn the heater on full blast? Do I turn it at some partial temperature or energy? Do I vary that? And the algorithm will take these PID constants and be able to better control with less over and undershoot, cycling around your set point type of thing, your system. And in this case, we're using it for our nozzle heat. We have our values now. So it says PID auto-tune finished. That means it actually went through the whole process. It was able to calculate new values for P. There's the P, there's I, and there's D. You can still see our old values. They're still on the screen right here. So they're in the same ranges, but they're different numbers than they were before. So if I wanted these new numbers, now these are based on 3 cycles. The previous ones were based on 8 cycles. I'm going to go with the 8 cycle one. But if I wanted to replace these, the old numbers, with these new ones, maybe I've done a change or whatever, then how I would do that is I would go and use the command M. So 303 was generate the numbers for the nozzle. 301 is save these numbers that I'm about to tell you into the file. So M301 P, and I would take, it looks like 18.77, and then I 1.39, and D 78. No, that's right. Oh, that's my old number. 63.17, and hit enter, and it would put those P, I, and D numbers into the printer, into its memory, so that it would use those numbers from now on. It wouldn't do it permanently, though. I would have to add one more command. So I don't want to hit enter on this because I don't want these numbers. I want my old numbers, and I don't want to sit through the process of doing it again. So let's pretend I hit enter. Those are my new numbers. And then to actually make it where they stick, where they don't drop out again when I'm done, you do M500. So M500 saves all the settings, including those PID numbers, onto the printer, so that when I turn the printer off and back on, they're still there. So I can do M500 because it didn't actually change anything. And then, I don't know why I said no EE problem. That's kind of odd. But maybe because I didn't have any changes to save. So that would be the process of putting these new numbers into my printer, so that it has the best chance of getting in its current state with the material that I most want to use, of getting to a set point temperature and staying there, not really overshooting too much, not really undershooting too much. If you've done any of your temperature towers, you know that it could be 5 or 10 degrees on some materials. Really makes a difference on layer adhesion, print quality, all these things. And so if I'm constantly overshooting and undershooting, I've got these varying layer by layer material properties that probably I don't want. There's a few instances where you want that, but generally you don't want that. So hopefully this will replace the ending of the previous video that didn't have any sound. You can look in the video description for the written out walkthrough for PID tuning, and if you want to, it's pretty easy to do. And again, most printers, you just can do this same process in the printer screen itself. Same thing though, you do the PID tune here, you still have to remember to go to store settings. So your printer screen will also have an option for store settings. If you don't click that, then those new numbers that you just generated will only last until you turn the printer off. You turn it back on and it's got the old numbers. So if you want to keep the new ones, then make sure you store the settings. All right, I will see y'all Friday with some actually new stuff, 3D printing related. Thank you.